Today's lesson is all about exponents. So exponents, as a quick review, is the small number, okay, also known as an exponent, next to a larger number, also known as the base. We take the exponent and it tells us how many times to multiply the base number. So that means I would do 6 times 6 times 6. Be careful and don't fall into the trap of doing 6 times 3. That's not what it is. It's telling us to do it 3 times. So in this case, I would do 6 times 6 is 36. And then I would take that number and multiply it one more time by 6. So in this case, it's 18, 21. So 216 is 6 to the third power, or 6 to the third power is 216. Today, we're going to talk about how to apply this with fractions, and it's really not as tricky as it may sound. I'm just going to leave the answer to our last problem over on the side so it can help us with this next example. We can also use exponents with fractions, and the way it's different is that it looks like this. We usually put parentheses around the fraction before writing the exponent. So this is saying 1/6 to the third power. Really what it's saying is exactly like what we did in the first example where it was 6 times 6 times 6. Now it's just saying 1/6 times 1/6 times 1/6. And that's it. So if I do that, I multiply, when I'm multiplying fractions, I just multiply the numerators. So 1 times 1 is 1, times 1 again is still just 1. And then I'm going to do the same thing. You're going to notice the bottom is exactly the same as just doing 6 to the third. And we already did that math. So 6 times 6 was 36. We multiply by 6 one more time. And we know our answer is 216 because we did it in whole number form. So if you notice, you actually just apply the exponent to both the numerator and then the denominator. We'll try one more together. Here's another example. We would read this as 2/3 squared or 2/3 to the second power. And all it's saying is 2/3 times 2/3, right? We're taking the base, which in this case is a fraction, and we're multiplying it by itself this many times. So this one's pretty simple because it's just 2 times. So 2 times 2 in the numerator gives us 4, and the bottom is 3 times 3, which gives us 9. Notice that we just applied the exponent to the numerator and then the denominator. So if you like to do it separately and think of it as 2 times 2, and then do another problem that's just 3 times 3, and then put them back into fraction form, that also works. The next concept we'll talk about today, including exponents, is using it in expanded notation. So just to review, expanded notation is when we write a standard number and we expand it out based on its place value. So for example, this number, 2,793, could be written as 2 times 1,000 because it's in the thousands place, plus 7 times 100, it's in the hundreds. I ran out of space, so I'll just go to the next line. Plus 9 times 10, it's in the tens place, plus 3 times 1 because it's in the ones place. And that's this number in expanded notation. So how do we use exponents for this? Well, the way we do that is we're going to look at this chart, and you have one as well, which you can put into your math notebook. So in this chart, you can see the powers of 10 in this column, and you can also see why it works. So if, for example, you're talking about 10 in standard form, for example, like this number, the way we would write it with an exponent or the power is 10 to the first power. So I'm basically just going to take all of these second numbers and replace them with a 10 raised to a certain power depending on the place value. We won't get any bigger than 1,000,000, but it's good to be exposed to this information. So let's look at our chart and we'll work through this expanded notation example that we already have. So if I go to the first section and I look at 2 times 1,000 because of the 2,000, I'm going to erase that 1,000 and instead I'm going to replace it with the power for 1,000. You can see this because it's really like saying 10 times 10, which is 100, times 10 again, which would give me 1,000. So the shortcut for that would be 10 to the third power. So in place of that, in my expanded notation, I would write 2 times 10 to the third power. And you're getting ready here for scientific notation is what it's called. So if I look at the next one, I'm going to, again, erase the 100, and I'm going to replace it with its power of 10. And in that case, the hundreds are going to be 10 squared because 10 times 10 is 100. The next one is going to be 9 times 10 because it's in the tens place, and 10 is written as 10 to the first. And then finally, the question is, what do we do with this 1? Well, I bet you can make a good guess. If I extended this table here and I wanted it to be a 1, all that's missing is 10 to the 0 power. And that's kind of different, and we haven't talked about it, but any number raised to the 0 power is actually the number 1. And so in my expanded notation, I'll erase the 1, and I will replace it with 10 to the power of 0. And I am done. You may notice a pattern. As long as you have digits in every single place value, so whole number digits, anything greater than 0, once you figure out what your starting power is, the rest of them are just going down by one number. If you had, for example, a 0 here, you would just skip this whole step and you would jump straight from 10 to the third to 10 to the first because there is a 0 in the hundreds place. So this is how you use powers of 10. And for now, you can definitely rely on the table. You won't need to memorize it for now, but you can definitely see how it works by using your table and referring to it with expanded notation. And that is how you use exponents in expanded notation. Now you try this one, 426. How would you start this? The place value of the largest number is in the hundreds place. So if I go to my chart, I'll see right here that I need 10 squared. So I will do 4 times 10 squared. That's just like saying 4 times 100. Plus, now I move on to the second digit. That is 2 times, this would normally be 10, but because I don't want to say 10, I want to use powers, I'm going to go over to my table and I see it's 10 to the first power. And then the last one, as I mentioned, is not on our table, but it would be 10 to the 0 power. So I would do 6 times 10 to the 0 power. And that's as easy as it is.